As I was saying, this training is brought to you by the Ghana R user community in collaboration with Elite Research and Data Science Institute. So today we are looking at data handling and then basic operations in R. My name is George Ajen, and this is my email address. So we are looking at data handling and basic operations in R. So the outline is like this. We first look at the basic R syntax and then command. And then we look at the different data types and structures. And then we look at the basic operations that you can perform in R. So by the end of this tutorials, you should be able to have a solid understanding of R's basic syntax, know your way around the various data types and data structures, and then be equipped to start your journey in mastering R. So we will start by looking at the R syntax, understanding the R syntax. So R is case sensitive. When I say case sensitive, what I mean is that uppercase and lowercase are interpreted differently in R. So if you type a name with lowercase and then later you come back to type that same name in uppercase, then R will treat them differently because R looks at them differently. And then when you are executing codes or when you are writing commands, they are executed line by line. So you can run commands directly in your console. I'm sure I showed you what a console is in our previous meeting. So you can write your code in a console or save them in a script. And then you can also write comments in R by adding or using the hashtag or the pound symbol. This image here shows a brief description of what I just said. So once you write a code that begins with a hashtag, R considers that code as a comment. So a comment is like information about your code, which is not run as a code. So once you start writing anything that begins with a hash sign or a pound symbol, then it means R is not going to recognize that as a code. So as you can see here, this is a snapshot of the R console. So I have my comments with the hashtag and then print. So the print is actually a command. So the print is used to show the output of variables. So the print and then inside I write hello world. So the hello world is my my code. So when I print it, it will show the hello world. So as you can see, the hello world with the 1 in a square bracket is the output. And then the print with the hello world inside is my code. And then this is a comment with the hash sign is a comment. And then the 1 in square bracket is called index. So we'll look at what an index is later on, maybe in this slide or in our next meeting. So, so what you have to put in mind, like what you have to have at the back of your mind is that R is case sensitive, and then you can write comments by starting your statement or starting your code with a hash sign, and then codes are executed line by line, either in your console or in your script. So we can also use R to perform our basic arithmetics like the way we use our calculators. So we can do our normal addition, subtraction, multiplication, division, and then exponentiation, that is raised to the power. So here's an example. So this is also a snapshot from an R console. So the image at the top is a snapshot from the console, and then the image below is a snapshot from a script. So you can see that in a console, I see the outputs. The values in front of the one with the square brackets, those are the outputs. But in a script, there are no outputs. You see only codes in a script. So we write only codes in a script. And then we see the output in a console. When we run the code in a script, we see the code and then the output both in a console. So the image above, I am doing 2 plus 2, which is normal addition, and it's giving me 4. And then 5 times 3, the star symbol or the star sign is used for multiplication. And then the forward slash is used for division. And then this symbol, the hat sign, it's like less than sign, which is pointed upwards. So you can find it on your keyboard. It is used to raise to the power. So 2 raised to the power 3 is that symbol. So you can perform all these things in R just like you do in your calculators. And then we'll move on to variables. So when we talk about variables are, let's say, names or items that store data that can be used and manipulated later on. So let's say the 2 plus 2 that we saw earlier on. So this 2 plus 2, we could have stored it in a variable. And then later on, when we call that variable, it will not print 2 plus 2, but rather it will print 4 because the result is 4. So variables store data that can be used and manipulated later on. So if I wanted to use that number, the number 4 in another place or in another operation, I could have used the name of the variable to do that. So variables in R can be created using the less than sign and then a dash sign or the equal to operator. So mostly we prefer this symbol, the less than this symbol. I hope you can see my pointer. We prefer this symbol, the less than sign with a dash or with a subtraction sign. That is what we use to create variable. It is called an assignment operator. So these two items will work, but mostly we prefer this one. And then there are also rules in naming your variables or in choosing your variable names. So all your variable names can contain letters, numbers, underscores, and dots. But you cannot start a variable name with a number. And as previously said, R is case sensitive. So when you name your variable with small letters, and then later you come back and then you want that same variable, but then you are using a single capital letter in any of the names, then I will treat them differently. I will tell you that it doesn't know what you want. So you have to use, if you are using small letters, you have to use small letters throughout. If you are using capital letters, you have to use capital letters throughout, so that you don't cause any confusion for the R programming language. So this is an example. So you see that I have VAR1, and then I have that assignment operator, and I have 20. So it means that I am assigning 20 to the name VAR1. And then I also use the equal sign. So here I am assigning name to the variable VAR2. So when you want to see the output of your variable, you can use the print function, or you can just type the name of the variable. So on your right side, I have the output. So when I use the print function, see the output for VAR1. And then when I just type the name of VAR2, I also see the output of VAR2. So you can either use, when I want to view the output of a variable, I just type the name, or I use the print function. I just type the name and then I'll get my variable output, or I use the print function to get the variable output. But mostly just typing the name is faster because you don't have to type prints and all that. So let's say I want to use 20 later on in an operation. I don't have to type 20 again. I can use VAR1 because 20 is assigned to VAR1. So wherever I want to use 20, I can use VAR1. Then move on to data types. Variables are used to store data. And then each data in R have a particular type. So in R, there are several data types that we can use, but mostly the most common ones are the numeric data types, the character data types, the logical, and then the factors. So that is what we'll be looking at. When we say numeric data types, so numeric data types represent numbers, including integers and floating point. So a floating point is just a decimal number. But in R, you see that it is denoted by double. So whenever you see double data type in your R, it's just telling you that it's a decimal number. You see that I have created a variable num, and then I have assigned the number 42 to the variable num. Now, when I want to see the data type of any variable or any data that I have stored in my variable, I use the class function. So the class function will give me the name of the data type. So when I call class on num, you see that the output is numeric because 42 is a number. And then we come to the logical data type. So logical represents Boolean values, and then Boolean values are just true or false. So logical data types can take only two values, true or false. So you can create a logical data type the same way as we created the number. I assign true to the variable name logic, and then when I use the class function on it, it gives me logical, meaning it is a logical data type. And then character represents text or string data. So whenever you want to type a text or a string, it is termed as a character in R. But then for R to recognize it as a character, we need to enclose them in quotation marks. So it can either be double quotes or single quotes. So here I assign hello R to the character, so to the variable char. And then I use the class function, and then it is giving me an output of character saying that the variable is a character variable. Then we move on to factors. So a factor represents categorical data. So in R, if you want to represent any categorical data, we use the character data type. Sorry, we use the factor data type. So it's useful for representing data with a limited number of unique values, like gender. So you see gender, let's say you have male, female. If you want R to recognize gender as category, then we use the factor function. So if you just do male, female, R will recognize it as a character because you have just enclosed them in quotation marks. So R will recognize them as a character. But then if you add the factor function, R will recognize them as category. So it will know that male is a certain category and then female is also a certain category. So we can do the same for, let's say, the university levels that we are in, let's say level 100, level 200, level 400, level 300. So you can use the factor for how to recognize the 100, 200, 300, 400 as categories. So that is what the factor data type is all about. It's all about representing categories in your data. So you see that with this factor, I have a factor function here, and then I have a C inside here before the male, female. We will look at what the C means later on in the slide. So I have assigned all these things, male, female, all these things inside the gender. So when I call the gender, I will see all these things. But then I don't want to see them. I just want to see their data type. So I use class function on the gender, and then it's telling me it's a factor. So just know that a factor is a category in R. Okay, so note, R stores all numbers as a float type. To store it as an integer, append L to the number or use the as.integer function. Any number that you type in R, it is stored as a decimal number. Although it is a numeric number, R sees it as a decimal number. Even if you type a whole number, it will not show as a decimal number, but then the data type is seen as a double, which I said previously, it's just a decimal number. So if you want to specifically use integers, so integers are whole numbers. Say you are counting the number of people in a house, and the number of people cannot be decimals or number of houses, then you might want to store your numbers as integers. So if you want to store your number as integer, just type the number and then add L at the end, capital L at the end, and then R will store it as an integer. But then if you just type the number, it will still be a number though, but it wouldn't be an integer. So you can also use the as.integer function. So there's a function in R called as.integer, which can change numbers to integers. So as.integer, and then you put the number inside a bracket, and then it will change the number to an integer. So just take note of this one. We are looking at operators in R. So we've seen some of the operators earlier on, seen the addition, subtraction, the division, and then the multiplication. But then these are just basic arithmetic operators. There are other operators in R. So we have relational operators. So the relational operators, they are used to compare values, and then it returns a logical value. So when you use a relational operator, it will not return a number, it will return a logical value. So it will return either true or false. Now you see that I have two equal signs and I am saying it is equals. So in R, two equal signs mean equals. So when you want to equate two items, we use two equal signs. So as you've seen earlier that when you use the one equal sign, you are not equating items. You are just assigning an item. So we saw that earlier on that you can use one equal sign to do an assignment. But mostly we don't prefer the equal sign. We want the assignment symbol, the less than and then the dash. So one equal sign does not mean equate in R. One equal sign means assignment. Two equal signs means you are equating the left-hand side and then the right-hand side. So if I have 5 equals 5, it will give me an error because you cannot assign a number to another number. But then if I have 5 equals 5, then it will give me true because 5 is actually equals to 5. And then the next relational operator is the not equal. So the not equal is an exclamation sign and then one equal sign. So when you see exclamation sign and one equal sign, it means not equal to. So if I have 5 and then I have the exclamation sign, one equal sign, and I have 4, it means 5 is not equal to 4. And this will give me true because 5 is not equal to 4. But if I have 5 is not equal to 5, it will give me false because 5 is actually equal to 5. And then we have our normal, our usual greater than and then less than symbol. So we can also add an equal sign to the greater than and then we get greater than or equal to. And then we can add an equal sign to the less than and then we get less than or equal to. So in the first box, the bottom left, I have assigned 10 to A and then I have also assigned 20 to B. So if when I want to add them, I do A plus B. But then I also assign the addition to a variable called sum. So sum will store the result of A and B. And then if I want to do subtraction, I do A minus B. Then I'll also store that in a variable called difference. So difference will store the result of A minus B, same as product will store the result of A times B. And then quotient will also store the result of A divided by B. And then power will also store the result for A raised to the power 2. So that's how it works. A is 10, B is 20. So A plus B will give you 30. A is 10, B is 20. So A minus B will give you negative 10. And then on my bottom right, that's the second box. Same, I assign 10 to A and then 20 to B. And then I check the equality of A and B. So I do A equals B with the two equal signs. And then this will give me false because 10 is not equal to 20. But then if I do the A not equal B, it will give me true because A is 10 and B is 20. So 10 is not equal to 20. So I do A greater than B, A is 10, B is 20, A is not greater than B, it will give me false. And then A less than B, this will give me true. So relational operators return logical values. But then these are not all, there are others. So we will look at the others also. So we also have logical operators, and then we have assignment operators. So the assignment operators, I'm sure you've seen them already. The assignment symbol, the usual assignment symbol is called leftward assignment because mostly we want to assign items on the right to items on the left. But then you can turn it and then do a rightward assignment. But then the symbol too must change. So the pointer should point to the variable name. So whenever you are doing an assignment, whether leftward or rightward, the pointer should point to the variable name. And then the equal sign is always for leftward assignment. If you try to put the variable name on the right, it will give you an error. So the one equal sign is for assignment, but then it is only for leftward assignment. So the variable name should always come on the left, and then the data or the item that you want to store in the variable should come on the right when you are using the equal sign. But then when you are using the assignment operator, you can turn it and then put the variable on the right and then your data on the left, or use it the normal way, your variable on the left and then your data on the right. And then we also have logical operators. So the logical operators are used to perform logical operations. So what do we mean by logical operations? So logical operations are basically and, or, and then not. So the and symbol, you see that there, and then the or symbol is this pipe, the straight slash, and then the not is the exclamation sign. So I am sure you have already seen the not because we saw it in the not equal to. So the exclamation sign means not, and then we just brought the equal sign, so it means not equal to. So that is what they mean there. This symbol, the end symbol, means end. The straight pipe or the straight slash is or, and then the exclamation symbol is not. So we have examples here. The logical operations are performed on logical values. It only works on logical values, and then the logical values are true and false. So I have bottom left A assigned to true, and then A assigned to true, and then B assigned to false. If I do A and B, I'll get false. But then if I do A or B, I'll get true. If I do not A, I'll get false, because now the reason why I'm getting false for end and then true for or is that when you use the end, it checks the left hand side and then the right hand side, and then both left hand side and right hand side should be true for end to give you a true output. So if you want your output to be true, then A should be true and then B should be true. But then B is false. So it means the end will also be false. But with the or is taking whether one of them is true. So we see that A is true. So it will give me true. Although B is false, if I use or, it will give me true because it is checking if one of the two relations or two logicals are true. So the or will give you a true when you have true or false, but the end will give you a false when you have true and false. But then if you have true and true, it will give you true. And then if you have false and false, it will give you false. For the or, if you have true or false, it will give you true. If you have false or true, it will give you true. The only time the or will give you false is when you have false or false. When you have false or false, then it will give you false. And then with the leftward and then the rightward assignments, we just change the direction of the symbol, the assignment symbol, and then we change the location of the variables and then the data. So the equal sign is always used for leftward assignments. So I have x equals 5. If I do 5 equals x, it will give me an error because you cannot use a number. So it will tell you that you cannot use a number, you cannot use a number as a variable name. So we have seen arithmetic operators, the addition, subtraction, and then we've seen relational operators, the greater than, the less than, the equal to, and then the not equal to. And then we have seen logical operators. And then we've also seen the assignment operators. There are other operators. Those ones will come in as we go on. But these are the ones that matter right now. So we've looked at the basic operators in R, and then we've looked at the data types in R. Now we are looking at data structures. So R provides several data structures to store and manipulate data. So for this lesson, we shall look at the most commonly used data structures. They are vectors, matrices, lists, tables, and then data frames. We've seen that data in R can be either a numeric, a logical data, a character data, or a factor. When you bring all these data types together, then you get a data structure. And then R provides several ways in which you can store these data types as data structures. And then the first one that we are looking at is a vector. So a vector is a sequence of data elements of the same type. So it's one of the most basic data structures in R. Vectors are created using the C function, which stands for combine or concatenate. So this is where the C comes from. You saw previously in a factor data type that I had factor, and then inside I had C. The C into bracket, all those values was a vector. If you want to create a vector in R, you need to start with a C. So you bring C, and then you can put any amount of items in a bracket followed separated by commas. So if you don't do that, if you don't bring the C and then you start putting items in the bracket with commas, then R will give you an error because R doesn't know what the comma is. But then when you bring the C, then R will know that, oh, okay, you are trying to put or combine more values in the bracket. So the C means combine or concatenate. So you can perform arithmetic operations on vectors, and then the operations are applied element-wise. The arithmetic operations are the addition, the subtraction, the multiplication, and then the division. So you can only do that for numeric vectors. So vectors come in various forms. We have character vectors, we have numeric vectors, and then we have logical vectors. A vector is a sequence of data elements of the same type. So just put that at the back of your mind, that vector contains data of the same type. So you cannot have a numerical vector, so a numerical and then a character vector in the same vector. So you cannot have two data types in the same vector. It should be only one data type. And then these arithmetic operations can be performed on vectors of the same data type. So here's an example. So here I create a numeric vector and then a character vector. So the numeric vector, I have 1, 2, 3, 4. And in the character vector, I have apple, banana, cherry. And you see that in front of all of them, there is C there. So there is C in front of all of them. And then the C is actually telling R that we are creating a vector. So whenever R sees a comma, it means we are adding more values inside the bracket. So with the arithmetic operations, we see that I created another numeric vector called VEC, and then I multiplied it by 2. So you see that the 2 is multiplying each element in the vector. So 2 by 2 will give you 4, 2 by 4 will give you 8, 2 by 6 will give you 12, and then 2 by 8 will give you 16. And then I can also add. So I add the VEC to itself. So 2, 4, 6, 8, I add it to itself. So 2 plus 2 will give you 4, 4 plus 4 will give you 8, 6 plus 6 will give you 12, and then 8 plus 8 will give you 16. So doing vector plus vector is the same as multiplying the vector by 2 because you are adding the vector by itself. So you can also divide by a number. You can find the exponent. You can raise to the power. So you can do vector raised to the power 2. And then it will raise each element in the vector by the power 2. You can do division. You can do all the basic arithmetic stuff with your vector. And then the next is a matrix. So a matrix is a two-dimensional array that holds elements of the same type. So the vector is one-dimensional, but then the matrix is a two-dimensional array that holds elements of the same type. So a matrix is also holding elements of the same type. So you cannot have different data types in a matrix. So a matrix can either be numeric or a character or a logical matrix. So it's essentially a collection of vectors with a specific number of rows and columns. When you combine vectors with specific number of rows and columns, then you get a matrix. So matrices are created using a matrix function. So there's a function in R that is used to create a matrix. And the name of the function is called matrix. Very simple, straightforward. So similar to vectors, we can perform arithmetic operations on matrices. To perform a matrix multiplication, we use the percentage star percentage operator. For basic arithmetic multiplication, it is just the star. If you use just the star to multiply two matrices, it will multiply them element-wise. So it will pick the first element and then the first element in the second matrix and then multiply it. But I know most of us know what matrices are, and we know how matrices are multiplied. So the single star will not do. So in R, if you want to do a matrix multiplication, you use a percentage sign, and then you bring the star, and then you bring another percentage sign. And then R will know that, oh, okay, you want to perform a matrix multiplication. Then it will do the matrix multiplication for you. So I have examples here that I will show you. First, I create my matrix with the name mat. So I create the matrix with the matrix function. So you have to specify the number of rows and then the number of columns. And then the items that you want to be in a matrix. So the 1 column 9 means that I want to create a sequence of numbers from 1 to 9. So 1 to 9 means I have 9 numbers. And then the number of items in a column, in a matrix should correspond to the dimension of the matrix. So here I have 3 by 3 matrix, which means I have 3 times 3. So the number of items should correspond to 3 times 3. And 3 times 3 is 9. So it means that the 9 items will actually be able to fill my 3 by 3 matrix. So if I want to do a simple multiplication, so I want to multiply each element of the matrix by a certain number, I just do the matrix times the number, and then it will multiply each element by the number that I want. And then if I want to do normal matrix addition, that is element-wise addition, then I use the plus sign. If I want to do element-wise multiplication, then I use the single star sign. But then if I want to do matrix multiplication, then I use the percentage and then the star and then the percentage. So here, creating a matrix you can see that I have created a matrix, a 3 by 3 matrix with the values 1, 2, 3, 4, 5, 6, 7, 8, 9. So the numbers 1 to 9 are arranged by column. So you see that it is 1, 2, 3 from column 1, and then in the second column, it goes from 4, 5, 6. But then we can change the way it is arranged. There's an argument that you can specify in the matrix function called by row. Automatically by row is, sorry, the default for by row is false. But if you want to use by row equals true, then you can change the by row argument to true. And then the numbers will be filled by row. So instead of having 1, 4, 7 in a row, then I'll have 1, 2, 3 in a row. And then the second row, I have 4, 5, 6. But here it is filling by column. This is the default way a matrix is created. And then multiply matrix by a scalar. So here I am multiplying the matrix by 2. You see that it is multiplying each element by 2. So 1 by 2 is giving me 2. 4 by 2 is giving me 8. 7 by 2 is giving me 14. 9 by 2 is giving me 18. So you can see that each element is being multiplied by 2. And then down here, I have matrix addition. So I add the two matrices. And then it is doing element-wise addition. So it adds 1 plus 1, 4 plus 4, 7 plus 7, 2 plus 2, 5 plus 5, 8 plus 8. And then you can see the values here. The output is what's showing here, the bottom image. And then at the top right, I have multiply corresponding elements. So this is different from the matrix multiplication. So multiply the corresponding elements means 1 times 1, 4 times 4, 7 times 7, 2 times 2, 5 times 5. And then matrix multiplication. This is what we were taught in school. So when you do that, this is what you get for the matrix multiplication. So just know that if you want to do a matrix multiplication, you don't use the star. You use a percentage sign, 2 percentage signs, and then the star in the middle. So our next data structure is a list. So a list is a versatile data structure that can hold elements of different types. So a list is versatile. So a list can hold elements of different types. So you can hold a vector in a list. You can hold a matrix in a list. You can hold another list in a list. Or you can hold individual items in a list. You can hold a single number, a single text, any type of data type that you want to hold in a list, you can hold it in a list. If you want to create a list, use the list function. Just like the matrix, use the matrix function. Here, use the list function. And then elements in a list can be accessed using double square brackets. You can access an element. Let's say you have different data types, vectors, matrices inside a list. And then maybe you want to retrieve the matrix or you want to retrieve the vector in a list. So you can access that matrix or vector that you want to retrieve using 2 square brackets or using the $ for named element. So if the elements in the list is named, then you can use a $. You can use the $. But if the items are not named, then you use the 2 square brackets. Use the 2 square brackets. So I'll show you how a list is created and then how we can also access their elements. So here I assign this list to a variable called a list. So here I have a number, I have a text, and then I have a logical value. So it is storing all these things inside a list. I can name these items. You see here, I am just putting the items there, but I can name the item. So I create another list and I assign it to list underscore n. But here I have named the item. You use the double square brackets when the items in the list are not named. But when the items are named, then you use the $. If the items are named, you can still use the square brackets, but then you cannot use the $ if the items are not named. So the $ is actually used to retrieve items from a data structure, mostly data frames and then lists. And then the square brackets are used to retrieve items from all data structures. So you can use the square brackets to retrieve items from a vector. You can use it to retrieve items from a matrix. You can use it to retrieve items from a list. But then for a list, you need to use 2 square brackets. If you are retrieving an item from a vector, you use only 1 square bracket. So we'll actually look at that in another session where we'll look at data manipulation and all that. So we will look at indexing, and then you see what the square brackets and then a $ means. So here I have a named list, and then here I have an unnamed list. So I use square brackets and I put 1 inside. So what the 1 is doing is it is retrieving the first item when I use the square bracket with the 1 inside. it is retrieving the first item from the unnamed list. So the unnamed list, I assign it to this variable LST. So if I call this variable and then I use the double square brackets and I put 1 inside, then it means I want this first item. If I put 2 inside, it means I want this second item. If I put 3 inside, it means I want this third item. But then for the name list, I use the $sign and then I use the name of the item I want. So the num here is for 59, the SMS here is for awesome R, and then I think it's for false. So if I want 59, I use num. If I want awesome R, I use SMS with a $sign. And then if I want false, then I use think with a $sign. So that is how the $sign and then the square brackets work. But we will look at them more in depth later on. Now we are looking at data frames. And these are the data structures that we will be working with mostly. So data frames and tables are types of data structures in R that basically perform the same function. So they store data in a tabular form. But then a data frame is a table or two-dimensional array. The data frame and then the matrix, they are all two-dimensional. But the difference is that the data frame can store different data types. But then the matrix can only store a single data type. So it is a two-dimensional array-like structure in which each column contains values of one variable and each row contains one set of values from each column. It is similar to a spreadsheet or a SQL table. So SQL is used for database manipulations, and then you can also use it for data analysis. But then it is not as advanced as R. But it stores its data as tables. The data frame looks like an SQL table or a spreadsheet item. So we all know spreadsheet items, the tables in an Excel sheet. And then the tables are modern versions of the data frames. But then the data frames and then the tables, they are the same thing. But I prefer using a table because a table looks nicer and then it is not as clumsy as the data frame. But then they are the same thing, so it doesn't matter. If you want to use a table, then you need to install a certain package called a table. So the table package is found in the tidyverse collection of packages, and it provides a better handling of data frames with large data sets. So data frames are created using the data.frame function. So there's a function in R called data.frame. And then tables are also created using the table function. But then you need to load the table or dplyr package first. In order to use the table function, you need a package. You have to install the package first. I'll show you how to install a package. So you need internet to install a package. So you need the table package or the dplyr package. And these packages are part of the tidyverse package. So I recommend that you install the tidyverse package. The tidyverse package contains a lot of useful packages that is used in manipulating and tidying your data. If you install this table package or dplyr package, then I will recommend that you install the mother package, which is the tidyverse, and then all these things will be installed for you. An example here on how to create a data frame. So I use the data frame function and then I specify name. So the name is actually my column name. And then I specify, so you see that I am just creating a vector and then I am giving it and I am assigning it a variable name. So I create a vector, a character vector, Alice, Bob, Charlie, and then I give it the variable name. And then I also create a numeric vector, 25, 30, 35. I give it a variable name age. Now, when I finish creating this and I print it, you see that it will create a table for me with the name, age, and score as the columns, and then Alice, Bob, Charlie as the row values. So the table, the same thing, use the table function. The same way that you create a data frame is the same way that you create a table. As I was saying previously, you can access data frame or table elements using the dollar operator or by indexing with a square bracket. So you saw that in a list, I was using 2 square brackets, but in the data frame, I am using only 1 square bracket. Assign the data frame to a variable called df. So if I call df and I use the $sign, you see that it will list all the column names for me. When you are using RStudio, that's it. So I can pick whichever column name that I want, either the name, the age, or score. So I want to access the age column or the age variable. So I do df $age, and then it prints the values under age for me. But then look at how it is printing the value of age. And then look at how it is printing the value of score for the table. for the square brackets, a table, as I said, or a data frame is two-dimensional, just like the matrix. So you see that I have the square brackets and I bring a comma and then I type 3. So the first item before the comma is a row index, and then the item after the comma is the column index. So inside the square brackets, item 1, comma, item 2 is row, comma, column. So here I only want column 3. So I left the row part. If you leave the row part, then it means it will print out all the row values. And I only have 3 row values. And then I called in the third column. So it is printing the score, which is the third column. And then see how it is printing it. And then see how with the data frame, see how it is printing it. You see that with the table, it is still showing me two-dimensional. It is saying 3 by 1. So it is still showing me a two-dimensional data frame. But with the data frame, it is only showing me like a series of numbers, 25, 30, 35, which is basically a vector. So that is the difference between the table. This is also another difference between the table and the data frame when you index items. I also created some differences between the data frame and then the table. So the key differences between the data frame and the table. So the data frame shows all rows and columns when printed, but the table shows only 10 rows and as many columns as can fit on your screen. So when you extract a single column from a data frame, it becomes a vector. But when you extract a single column in a table, it remains a table. So you saw it here. When I extracted the age, it is showing as a vector, but here you see that it is still two-dimensional. So it is still a table, or it is still a data frame. So data frames recycle values when adding a new column with fewer rows. A table does not. A table will give you an error. So let's say this data frame, name age score, and then I want to add another column called height. But then instead of adding 3 items, I only add 2 items. For the data frame, it will recycle the 2 items. So the first one, it will bring it at the last one to make it 3 items so that it will fit here. But with the table, if I am supposed to print, I'm supposed to create a height with 3 items, and then I use 2 items, it will give me an error. And then for data frames may change the data type of inputs, especially character to vectors. So mostly sometimes, especially when you are importing, like when you are bringing a data outside R into R, and then you use the data frame on it, sometimes it might change any character variable to a factor. But for a table, it doesn't do that. You have to change your own character to a factor intentionally. But sometimes for the data frame, it might change a character to a factor. The last one is automatically converts non-standard variable names to valid R names. The non-standard variable names, as I said, you cannot start a variable with a number, or you cannot leave spaces in a variable name. When you do that to create a data frame, like say this name here, if I had start with a number, let's say 1 name, then the data frame will automatically correct the 1. And let's say maybe put X there or something. But when I use a table, it will still use the 1 name, but then it will put them in inverted quotes. So when you see any name in your table that is put in inverted quotes, then it means that it is not a standard variable name. So these are the key differences in a data frame and in a table. I would like to go inside the RStudio. If anybody has a question, you can ask if anybody has a question. So I'm just demonstrating how you create a variable in R, how you can add variables, how you do the relational, you can use the relational operators, logical operators, how to create a matrix, a list, and then how to create a data frame and then a table. So I want to create a variable called name. So this symbol, the less than and then the dash, there's a shortcut. So I'll type it in the chat, control plus this sign. So I hope everyone sees it. So the control plus the dash will give you this symbol, the assignment symbol. So I want to create a character vector called name. So I start with my C, and then I'll put George, and I'll put Vincent. So I have created a character variable here. So I have created this vector, and then I have assigned it to a variable called name. So if I want to see the items, I just type name, and then you see that I have George, Vero, Vincent, Doris, and then Francis. but then I could have equally used print name, and then it will still show me the same thing. So you can use the print function, or you can just, so mostly I prefer using just the variable name, and then you get your values. This is a character vector. So I can use class name to check the type. So you realize what is happening here. Error, object name not found. So remember I said R is case sensitive, but then I use capital N, and now I'm using small n. So R is telling me that it cannot find the object name. It means I didn't take my own advice. So now I have used the capital name, and then you see that I am having a character. So the vector is a character vector. So I'll create another vector called age. All right, so now I have my age. So 20, 30, 23, 31, 26. So this is also a numeric vector. So I can use the class function to check. So you see that I have numeric. Now I'll create just a single item, x equals 15, and then y, I'll assign it to 20. So I want to do simple addition and subtraction. I can do x plus y, then I get 35. Can do x plus x, I get 30. Can do x times y, get 300. Can do y divided by x, get 1.33. So this is the quotient. So I can do y raised to the power 2, I get 400. So 20 raised to the power 2 is 400. So when I call x, I get 15. When I call y, I get 20. These are some simple arithmetic operations, and then we've seen how vectors are created. Now let's see how to create a matrix. So with a matrix, we use a matrix function. So here, I have to create the data that I want in a matrix. So I can create a vector inside the matrix 2, 4, 6, 8. So I have 4 items here, and then number of rows equals 2, number of columns equals 2. So I have a 2 by 2 matrix with 2, 4, 6, 8. So let me store the matrix, my matrix, in a variable called my matrix. If you want to go back to all the codes that you type in now, you can press the up arrow key on your keyboard. The up arrow will bring back all the codes that you've typed in now. And then if you want to clear your console, when I press Control L, it will clear my screen. Okay, someone wants me to write it in an R script. I don't want to be typing again. I'll just copy and paste in the script. So name, just copy this, then paste it in the script. So if I want to run, I just use this run here. So this symbol here, when I click on it, it will run it for me. Here it will run. But the cursor should be in front or behind the code that you want to run. Or you can use Control and then enter, and then it will run your code for you. Now I have created a matrix. So I have my matrix. So when I call my matrix, then I have my 2 by 2 matrix here. So I can add my matrix plus my matrix. So when I add them, you see that it is doing element-wise addition. So I have 4, 2 plus 2, 4, 4 plus 4, 8, 6 plus 6, 8 plus 8. And then I can do element-wise multiplication. And then I can do matrix multiplication, which is the percentage star percentage. And then you see that it has done it for me here. So let me create my x variable. So this time I'm using the equal sign to create the variable, and then y. So I'll run it. So I'll do the relational x is greater than y. Let's see what's happening. So it's false. X is 15, y is 20. So x is not greater than y. So let's look at x is less than y. This is true because x is actually less than y. And then let's look at the equal to, the true equal sign. So this is false because x is not equal. X is 10, y is 20. X is 15, y is 20. So they are not equal. But if I do x equals x, let's see. This is true because 15 is equal to 15. So these are the relational operators. Let me assign this to another variable called a. And I'll also assign this to another variable called b. I want to do the logical operations on them. So I'll do a and b. I'm getting false because, so let's look at what a is. A is false, b is true. So since one is false, it is giving me false. But then if I do a or b, it will give me true because one of them is true. But if I do not, so not a, not b, it means it is not a or it is not b. So not a, okay, so the not is like the opposite of the logic. So b is true. So if not b, then it is false. So if a is false, then not a means true. So let's look at how we can create a list. So let me clear the console here. So the list, I have name, I have age, I have my matrix, I have x, I have y, I have all these variables. I'll name the list my list, and then I'll create the list. So I put name inside, I'll put age inside, I'll put my matrix inside, I'll put X, I'll put Y, put A, I'll put B. So if I check, just type my list. So you see that I have all these items here. George, Vero, Vincent, Doris, I have 20, 30, I have the matrix, I have X, I have Y, I have A, I have B. So this is an unnamed matrix. So if I want to retrieve any item from the matrix, let's say I want the 7th item. So this thing should even give you a clue. So you see that this is enclosed in 2 square brackets. So if I want it, I just use my list and then I use 2 square brackets and then I input, let's say 3. So it means I want the 3rd item. So it will print out the matrix for me. So this is actually the 3rd item in the list. So it will print out the matrix for me. If I want the 1st item, I can use 1. I use 1 and then I have my first vector here. So this is how you create a list. You've seen how to create a vector. You've seen these. Let's go to the table. So the data frame. So with the data frame, we use data dot frame. So I'll save it my df and then data dot frame. So I'll use the name that I already created. So I already have a vector called name. So I'll use the name and then I'll use the age and then I'll create another variable called height. So the height, I'll put some values here, 160, 166, 154, 171, 180. So I have name, age, height. So let me just run this. So if I call my df, so my df, you see that that's created the data frame nicely for me here. So I have 5 rows and then 3 columns. So I have name, age, and height. So 1, 2, 3, 4, 5 rows and then 3 columns. Very nice. If I want to retrieve, let's say the height column, I can do my df dollar. See that all the columns are coming. Then I choose height. Then it will print the height values for me. Same thing if I want to choose the name, my df dollar name. And then it is choosing the name for me. Or I can use the square brackets notation. So my df, so I told you that with the square brackets, the first item is your row, and then the second item is your column. So we leave the first item because we want all the rows. And then we use, so you can either use the number of the column or the name of the column. So first I'll use the number. So I'll use 1. So the first column. So the first column, you see that it's giving me the same as the df, my df dollar name. I can equally use name. So name, but I have to put it in quotation mark. With the table, we need the tidyverse package. So if you want to install a package in R, so you come here, tools, install packages. So it will open this, and then you type the name of the package, tidyverse. Then click install dependencies, and then I'll install. So when I click on the install, it will type some code here, and then it will start installing. But you need internet to do that. So it is saying that I am already using those packages, so I have to restart. I already have those packages. So if you want to install them manually without going, you can type install.packages and then do tidyverse. You type the name, put it in quotation marks, and then you run it. Then it will install for you. So let me type it here for you guys. Install.packages, tidyverse. So when you finish, then you do library. So once the package is finished installing, you need to call it tidyverse. So tidyverse, so you need to call it. So library tidyverse after you've installed the packages. Now, if I add a hash sign here, if I add a hashtag to all the code, you see that it will change color. It means it has turned into a comment. So if I run it, it will show in a console, but it will not run any code. So that is how you create a comment. So let me just come up here, and then let me just add a comment for our training. So this is the comments for our training. This is the comments. So now I have loaded the dplyr package, so I can use the table. So the same way I did for this, I'll just copy this, but instead of the data frame, I'll use table, and then you will notice the difference. So instead of my df, I'll use my tb. So my tb, and then my tb. Yes, so you see how this is showing. You see that this is showing the dimension here, 5 by 3. But then with my df, it's just showing the data raw like that. But here you see the data types also. You see that this is a character, it's showing here. And then this is a double. This is a double. So the double I said is just a decimal number. And then you also see the dimension here. So you see the data types, and then you see the dimension. So I have a 5 by 3 data frame. So I have 5 rows and then 3 columns. So this looks much nicer than this. Let me show you another thing. When you have a lot of data, So there's a data frame in R called Boston, but it is found in another package called mass. So this is a data frame, a typical data frame. You see, when I run Boston, no, this is a table. So you see how the table is presenting the data frame. It is showing the first 10 elements, and then it appears nicer. Like, so it shows that there's 496 more rows, and then there are 3 more variables, because these are the only variables you can print on the screen. Then I can also change it to a data frame, data.frame. So I can use as.data.frame so that I see how the data frame looks. See how the data frame looks. This is too much. See how it is printing everything on the screen. It is trying to print everything on the screen. See how this looks. This looks crowded. With a table, you see that the table looks much nicer. So I prefer the table to the data frame, but then they are basically doing the same thing of storing data in a tabular form. But I prefer the table because it looks nicer and then simple. I think that will be all for today. This is just a small demonstration. I'll create an exercise file for you to try your hands on some of these things. And then if you have any problems, you can text me in a WhatsApp page. Okay, so I don't know if anybody has any questions. I didn't talk about this function. If you want to change from one data frame to the other. So now that you see that I have as.data.frame. So there's also another function for the table like that, but the table is not dot, it is as_table. So this will change, this will also change a data frame to a table.
Okay.
If you are creating it for the first time, just use data.frame. If you are creating it for the first time, you don't need to do the as. But then if you have the table in a table and then you want to change it to a data frame, then use the as.data.frame. Or if it's in a data frame and you want to change it to a table, use the as_table.
So I think, George, let me just so next week Friday, as Mr. George said, we'll continue next week Friday and next week Saturday. But then on Friday, we will be launching Kumasi R Ladies community. We'll be launching Kumasi R Ladies. So please, the ladies on this training session, I'm encouraging you to join next week, which will be around 12 to 1 noon before our main training. So I'm just inviting everybody to join the Kumasi R Ladies launch. Thank you very much. So George, over to you.
So moving forward, we'll be looking at using table files from different apps or file types now. So we'll be looking at importing data into R. You have your data in an Excel sheet. How do you import it into R? So we will look at how to do that. And then we will look at data manipulation, that is using the dplyr and then the tidy packages. And then we'll also look at loops, control structures. So if you want to automate repeating tasks, then you can look at using loops. So we'll look at that in our next session. So we'll look at importing data, we'll look at data manipulation, and then we'll look at loops. And then I'll also take you through some functions. So I will take you through how to create a function in R. I'll take you through the loops and then I'll take you through the functions. So I'll share some files with you before that. We look at them, the files that I'll be importing. Thank you very much for joining today's session, and then I hope to see you again same time next week. Goodbye.
Thank you.